So a little bit on the algorithm itself, right? So so what we wanted to do was to predict future car sales based on past 10 years car sales, right? So we have past 10-year car sales from the country of Norway, right, of all countries, and we have it broken down by year and also by month, right? So what we would like to do is to predict the car sales in 2018 and 2019 based on the past 10 years information and make decisions based on that. So for example, if a certain make and model is selling better in the month of December, then it probably makes more sense to have more promotions during that time, right? Christmas season, more people buy cars. Let's say if a certain make and model is not selling, then it obviously makes more sense to discontinue that model and concentrate on the model that actually people are buying on, right? So you can obviously make a lot of decisions, marketing decisions, manufacturing decisions based on predicting future sales, right? And this is just an example, right? So the same example will apply to retail, where if you want to predict user behavior, customer patterns, it's the same concept. For this example, I'm going to be using car sales data. Okay, so let's break from here and let's show you the demo. Okay, so the first thing which I would like to show you is our Okay, so this is our cluster in which I'm going to run these calculations, right? So this is a super micro cluster. So it's an 8-node super micro cluster. This has around 25 billion records, right? Around 24.5 billion records, around a little over 1.5 terabytes, around 1.6 terabytes. And then just to show you how your data resides. So these are your tables here. So you have essentially, let's say you take the new car sales table. So this is the table that we are looking at. So if you look at the table itself, you have concepts of columns like any other database. You have types, simple data types. You have properties. You can set primary key, foreign key. You can set indexes if you would like to. I have not set indexes. You have a concept of shard key. So if you want to partition your data based on how your queries are, if you want to do joins across multiple tables, you can do all of that good stuff, right? So just to give you an idea of how the data is, what I'll also do is to click on this UDF, the UDF link here. So the UDF link is where you can simply click and create and execute your user-defined functions, right? So right now I have 2 user-defined functions. We have the linear regression one that I'm going to demo in a second. And by the way, this was written in Java. We have another one here, risk management, which is written in C++, but you can write it in the programming language of your choice. So to add another one, all you have to do is to click the new button. You can specify the name, how you want to execute it, and then if you have, let's say, 10 files that need to be passed into the UDF, you can choose the files and you can run it. What you can also do is execute the UDF. So all you have to do is choose it and then click on execute, and then it's going to ask you the parameters that you need for it to execute. And then if you need an input table that you need to point to or an output table that you need to write to, you can specify that here as well. So so if you're a power user, you can execute it using this this UI. If you are a programmer or a developer or an architect, you can use one of the API that we support, and that is defined right here under kinetica.com/documents/user-defined functions. For the purposes of this demo, I'm going to be going against this dashboard. So this is our reveal dashboard. You can create graphs, you can create widgets, you can create bar graphs, line graphs, timeline graphs, heat maps, geographical maps with this data. So with the UI. So what we're going to do is first slice and dice the data based on various feature sets that we're talking about. So let's first select Ford, and let's select Ford Mondeo, right? So Ford Mondeo is a car that is a model that Ford makes that I did not know about before I started looking at this data. So it looks like for back in 2008, you had pretty good sales of this car, but in 2013 and 2014, it kind of plateaued out. And then the car sales did increase a little bit, but it looks like it's still on the lower part, right? So let's choose the linear regression algorithm, and let's predict the future car sales for the various months, January to December, based on the past 10 years, right? Let's sort by month. So what we have here is for the month of 1, which is January, the Ford Mondeo average is 247. Excuse me. The average sales is 247, but the sales for 2018 is projected to be only 61, and the sales for 2019 is projected to be only 32, right? So obviously, there's a steep decline from 247 to 32. That's for the month of January. If you look further down for the month of July, you could see that the average for the last 10 years was close to 300, but the projected for 2018 and 2019 is very, very less, and in fact, it's projected to be 0 sales 2 years from now, right? The similar for the month of December, but overall, we get the picture here, right? So the Ford Mondeo is, people are not buying this, or this model is not being sold enough, right? So obviously, if you're making a decision, Ford is making a decision to invest in a certain model, then Mondeo probably shouldn't be the model, at least in the country of Norway, based on the data that we have, right? So let's look at another one, which is a little more positive, right? So let's look at the Volvo XC60, right? So let's run the linear regression on this. From the graph, you can see that for the last 10 years, things have been ebbing and flowing, but for the last couple of years, you can see that sales has gone through the roof, right? So let's predict the car sales for this for the month of January and February and beyond for 2018 and 19. So for the month of January, the average sales is 177, but you can see that the average sales has increased. It's 236 and 245 going forward, right? And then if you go further down, you would see, let's look at the month of December, and that's where, you have the holiday sales season, right? So 379 cars has been sold for, as an average for the month of December, but you can see that the prediction based on our algorithm is that it's going to almost double, right? So you're going to have 588 in 2018 and 626 in 2019. Someone told me, one of my colleagues told me that the Volvo XC60 has a seatbelt problem, right? But it looks like that hasn't affected the car sales, and it's predicted to be even higher. So they obviously will have to fix the seatbelt problem, but it looks like you can now invest in this Volvo XC60, right? So you can make decisions based on this data. This is just one algorithm. You can run multiple algorithms very, very quickly with this data and gain your insights very fast. And then finally, what I would like to do is show you how this can be done from a Jupyter notebook, right? So there's a number of different ways you can call UDF. So we support Python, we support C++, and we support Java for calling and for creating and executing these UDFs. So what this does is it just uses Python. So we have specific import files, right? So you just go through this, import this. I have an internal cluster which is available only through VPN that I usually run this on. Excuse me. So I run this, and I connect to the stable called new car sales. I choose the model Ford for the purposes of this, and I filter it based on my filter criteria, and then I print the number of records returned, and then I loop through the records and I print it, right? So right now for the Ford, you can see that you have around 214 entries. So this is a little bit different than the demo that I did. For the demo, I chose Ford Mondeo, but this looks at all the different Ford models, and it calculates the quantity based on the year and the month of sales, right? Then I delete my projected car sales record, and when I run my linear regression algorithm, I try and execute the UDF. So all I have to do is pass in my table, which is my new car sales table, and that's the table I think I apologies. I think I showed you that table there, right? So that's this one here, right? That's the new car sales table right there, right? So this is the table that takes the input, and then if I go back, the output table would be the projected new car sales. So if I go back here, you can see that that's the name of the table. And then to execute the UDF in Python, all I have to do is that one line, right? So that takes care of it. And then when I sort the results, I look at my output table, and I parse the output table ascending, and I sort by the make. Sorry, I filter by the make, and I sort by the month, and I look at only the ones that are greater than 0, right? So you can see that I get similar results, right? For the Ford Mondeo, the average for the month of January was 247, but then we project lower numbers. The Focus is actually doing a little better, even though not that bad, not that better, not as good as the Volvo XC60, but you see that you have a little better sales. So you can execute this in multiple languages, but you get the picture here.